Our guest today is a partner in Construction Instruction, CI, and president of Building Knowledge Canada. He is a professional engineer with over 30 years' experience in the low and high-rise residential building industry as an educator and industry consultant. Combining building science principles and his strong, effective communication skills, he shares his insights with passion across North America. He advocates for better building practices and cost-effective methods for simultaneously improving the energy efficiency, health, comfort, and durability of new and existing homes. It is my pleasure to have Gord Cooke join us for this edition of Taking Care of Business. Welcome, Gord.
Thank you very much, Duane. Appreciate the opportunity. I always enjoy chatting with you.
Got the hat on.
I appreciate that. I was going to give you that shout out right
There you
away.
go, man. Got to promote,
Not a
no
problem.
doubt. Well, again, I appreciate you taking some time to join us. This is another, I guess we would say, episode or interview in this Taking Care of Business series that I'm doing with Custom Builder. And we're covering a broad range of topics, and one of the ones we were thinking about tackling was, and we'll have several episodes on building science, high performance, things like that. But I said, I know somebody that I really respect, and I know we'll have a great conversation. So we're going to dive right in. But as we do, why don't you just tell us your journey around being an engineer, educator, industry consultant, kind of where you started and how you got to where you are today.
Sure. My start in the industry was in the mid 80s, and I was designing and building on behalf of a small manufacturer something called a heat recovery ventilator, which I suspect most of your listeners will know what it is, but I'll challenge you to who would have known what that was in 1984. And as I was trying to promote those products, builders would say, why do I need that? And I'd say, because you're building tight houses. And they'd say, am I? I said, I don't know. So I bought a blower dryer, started testing houses to see if I could promote the concept. And then you'd find out they weren't particularly tight. And builders would say to me, should they be tight? And I said, I think so. And they would say, well, can you tell me more? So I took some training to figure out how to make houses tighter. And of course, so in other words, I was really just trying to promote a technology and found out that it was part of a much larger system, right? House is a system. In fact, that's a good old Canadian phrase. House is a system. Everything interacts with everything else. And I think that's what appealed to me most as an engineer was this idea of an industry that's very complicated industry. All your listeners know that, all your participants. I mean, what could be more intricate, more complex than building a custom house, right? A collection of 12 to 15 separate subtrades over a building site that's, maybe as much as a year and a half, 2 years in the making, but perhaps not on a regular basis that long, but a collection of materials and building for homeowners who have really no idea what it takes to build a house. It's very, very challenging. So to interject this idea of some science to this and how some things impact others. And I was always able nicely to say to builders, look, you guys experience things in the field. Some of those I can explain with some science, and that might help you avoid it again. And that was always a nice mix. They would show me what they were experiencing and the kinds of challenges that presented. I was able to go back and, in most cases, find the science behind that and say, hey, here's a way to approach that, to solve that. So it's always been really nice that way to be able to feel like I'm contributing to this complex world, trying to make things simpler for builders.
Yeah, I remember some of the early day, blower door testing. What was it that I guess, when we're thinking about blower door testing, we think of air leakage, air infiltration, but when did it really hit you that was an issue?
Yeah, it was actually very early on because where I was making heat recovery ventilators was a place called Saskatoon, Saskatchewan. It was kind of the birthplace of much of the building science. And so at the research center there was a couple of folks, Harold Orr, who was doing research on making houses tighter, and a fellow by the name of Dick Van E, who was doing research on making sure houses were healthier. And the two actually combined really nicely. And we realized that, boy, back in the day, we thought we could make houses just tight enough, some sort of dynamic wall, and just enough air coming in, and realized, nah, the pressures in houses change day to day, hour to hour, week to week, season to season. So trying to control the holes and the amount of air that came through the holes was impossible. The only way to control the system was to make the building enclosure airtight and then put in intentional ventilation. And back in the day, that could have been windows, and it was windows for years. And then at some point you go, well, people don't want to open their windows because of noise, dust, security, and energy costs. So I better give them another way of making sure they have proper ventilation. So that was one of the first building science rules: build tight, ventilate right. Build tight, ventilate right. And could you do it without? Lots of folks tried building just tight enough and never had success with it because the physics just wasn't there. Wind, stack, mechanical effects, really hard to control the pressures. The only hope you had was to control the building enclosure and then put in intentional ventilation.
Right. So when you started that, obviously energy efficiency, air quality, all that stuff is in mind. But how did it start to change as, I guess, as energy code changes and as we really just started to attack, homes really looking at mm, insulation, more insulation, more insulation. It drastically changed lots of things in a system, didn't it?
Absolutely. And the codes initially, and I always like to tell the story, high efficiency furnaces, for example, didn't make their way into codes and standards because they were energy efficient. That wasn't the deal. In houses in Minnesota and Dakotas, Washington, and all through Canada, we started using high efficiency furnaces because they didn't have natural draft chimneys. Because the problem with natural draft chimneys is they backdraft and they kill people. And whether the house is tight or not, everybody wanted big range hoods and bathroom fans and dryers in their houses. That was creating negative pressure. Chimneys were backdrafting. And so they held meetings. I was at those meetings as a young guy. Well, what should we do? Well, we should put in a makeup air device that brings in makeup air for range hoods and dryers and so on. And you realize that's a real challenging thing to do. It's way easier just to go to a direct vent sealed combustion furnace that really is immune to negative, more or less immune to negative pressure problems. So we ended up putting things in the code for health and safety that also magically made houses more energy efficient. And similarly, air tightness. Air tightness was not put in the code in the 1990s to make houses more energy efficient. It was to make sure that warm, moist air didn't leak into cold cavities, specifically in cold climates. Warm air does what? Well, it rises. And as warm air rises, moist air goes into an attic that's gotten colder. Why'd the attic get colder? Because we required more insulation. Well, if you put warm, moist air into a cooled attic, you get condensation. And you can talk all you want about ventilating that out, more roof ventilation. No, the easiest thing to do is to make sure the warm, moist air never gets in the attic in the first place. Make it airtight. So air tightness, you look at the the ICC in the US or the IRC, it talks about air barriers, has since the 90s, not for energy efficiency, but to ensure warm, moist air doesn't get into cavities, which means it makes houses more durable and healthier. So there's two examples of technologies that happen to be energy efficient, but more importantly, they make houses healthier, safer, more durable.
Yeah. And that's, again, just a part of all this stuff that we like to call building science. Um, Something I want to have you dig a little bit deeper on is, what is building science in the simplest of terms?
And I love that question. I was just on the line with two of the best building scientists in North America, John Straub and Graham Finch. We were talking about an issue of air leakage in buildings and so on. And they would legitimately call themselves building scientists. Of course, I'm old enough. I wasn't called a building science back then. And so we've kind of co-opted that term. But fundamentally,
maybe even might have been mad scientists back then, right?
Yeah, exactly. And there's others, of course, came before me that did it. But it was really, I would say studying the science of how buildings work. And some would say, oh, you mean structurally? No, that was already there. Structural engineers were already there. So we didn't need a term for that. Electrical, mechanical, okay, those are engineers that looked after how those bits and pieces work. But building science is really about understanding the flow of heat, air, and moisture across the building enclosure, right across the envelope. Understanding that we have a temperature, we've created these temperature differentials across our building enclosure. And we've created a bigger and bigger temperature differential. Time was when it was minus 30 outside, you were totally fine if it was 55, 60 degrees inside and you wore sweaters and slippers and so on. But now you would say, no, I want it exactly 72 degrees. I don't care what the temperature is outside. I want it exactly at 72 degrees summer and winter. That's what your homeowners would say. Well, now we need to understand the forces, right? If heat moves from hot to cold, moisture moves from more to less. If I have differences in moisture, differences in temperatures between inside and out, Mother Nature wants everything to be equalized, and heat flows. That heat flows from hot to cold is the same moisture from more to less. So that's really what this is about, and understanding those flows and the dramatic impacts it can have. Because when warm, moist air hits cold surfaces, it's going to condense. And moisture itself in the air isn't really a problem. There's been humidity in Florida forever, and it didn't really cause any problems until in Florida we started air conditioning buildings, and now that warm moist air from outside condenses on bathroom fans and dryers and on walls and so on, and oops, now I have a problem. So it's understanding the impacts of air, heat, and moisture flow, the change in air, heat, and moisture flow as it crosses a building enclosure, and using building materials that happen to be subject to those challenges. Right? We use
Yeah.
drywall, which is highly subject to moisture, and wood, highly subject to moisture issues. So that's what building science is: understanding the flow of heat, air, and moisture,
Yeah.
and how it might impact the building itself and the people within.
And you have to go about a lot of this differently based on, where you live and the climate you're in. But at the end of the day, the principles are the same. Correct?
And thank you for saying it that way, because I do work in I'm a Canadian, live and work in Toronto, Canada, but I do work in Florida and Houston. And when I first went down there, like, really, you understand this stuff? I said, well, we've been dealing with warm, moist air condensing on cold surfaces for decades. That just happened to be in winter. You guys are dealing with warm, moist air condensing on cold surfaces in the summertime. The physics is exactly the same.
Yeah.
And it's, how do I solve that? Well, one of two ways: I warm up the surface or I lower the humidity levels. Okay. I do that differently in Florida than I might in Canada, but the premise is exactly the same.
Yeah. And I was very fortunate to attend an event at Construction Instruction where you were out there. And, one of the things you said really, it hit with me. And I say it again to a lot of my teammates and other people that I collaborate with, because again, there is so much in the world of building science and high performance and net zero and certifications and just all sorts of stuff, green building, And you had said, at the end of the day, as builders, probably designers, builders, trades, whoever's involved, that the goal should always be healthier, safer, more durable, more comfortable while making it energy efficient.
Exactly. We spent, the early days, I would say back in the 70s, making incredibly efficient houses that weren't really health, safe, or durable. And now you'd say, no, we're not going to let that happen. And I'll go the flip. If you make houses healthy, safer, durable, and comfortable, you end up with an energy efficient building. So you can look at it both ways. Either way works. And I wouldn't necessarily recommend people do it for energy efficiency, because frankly, our clients still struggle with that. Energy costs are still so low that people aren't really, the minute you say it's going to be energy efficient, immediately people, what's the payback? What's the ROI? It's like, no. I want to make it healthier, safer, more comfortable, more durable. And by the way, it's going to save you a few bucks, but most importantly, you get those other things.
I don't think there's a client out there that doesn't want all those things, and there's
Sure.
not a builder out there that can't, and not even sell those, but position those things.
Absolutely. Totally
Yeah.
agree.
Again, without fumbling over green building, sustainability, net zero, all that stuff's great and it has its place. But I mean, I think if you approach it more from that bigger picture, things that everybody can understand and relate to,
Right.
it all starts to make a lot more sense.
My partner Mark has always said, don't chase bars, stars, awards, colors, numbers. Don't chase those. Just build a really good, warm, comfortable, dry, healthy building, and magically you'll have met the needs for the bars, the stars, the awards, and so on.
So in your time as an engineer and focusing on business science, I mean, give us what are some of the major changes or innovations that you've seen?
I think, and that's really useful. I can use a couple of examples. I use the example of heat recovery ventilation devices. That's a technology that 30 years ago, 35, nobody knew what it was. Now it's a reliable appliance, just like any other, major companies, Brown, Panasonic, just build wonderful equipment. It's quiet, it's efficient. It provides people with fresh air. What could be better than that? I ask homeowners all the time, when would you like fresh air in your home? Well, all the time. Exactly. Here's a device that does that without having to open windows and worry about that. So that's an example of a technology that's solved a nice little problem for folks. The others that I would say help address the challenges in our industry, because as I mentioned, building houses is really complicated. And what we have to work towards, my opinion is, we have to work more towards systems, and in which case I think we need to rely on manufacturers, the expertise of manufacturers. So we are at CI, you will know, we tend to partner with companies that understand the science and the trickiness, if you will, the complexity of building houses and trying to find systems that look after that. And, a good example is the water resistant barriers like a DuPont Tyvek provides, understanding that water's our enemy. We've always had to worry about it. And yes, we've had papers and different materials that will do with it and deal with water. But frankly, there's got to be a better way. When you think about the complexity of buildings, the design, how complex buildings have gotten, the different roof lines, the size of windows, the number of stories, the bump outs, and so on. And when you have a system of compatible materials, here, use all of this and take our training and have your trade contractors qualified, certified. That, to my mind, is an innovation. It doesn't sound like an innovation, but it's an innovation as a process or process. You guys would say, I'm a Canadian, so I'd say process. But making it easier to build, right? Rather than trying to take old materials and trying to jerry rig them into the new building materials, building designs. You think about, used to be brick in the Northeast, siding in the Northwest, stucco in the Southwest. Now you'll see buildings with all four claddings on, and you go, wow, each of those has different moisture movement mechanisms. Each of those has different characteristics. We really need a system behind that will work in all climate zones, in all seasons. So I think systems approach by manufacturers is really valuable. The other one, we've talked about air sealing, and it's always been a struggle, right? For 40 years, caulks, foams, tapes, miles and miles on the hip. I've done blower door testing. I've probably personally done 4,000 blower door tests. My guys here do hundreds in a year, and they will tell you every builder, rightly so, is nervous, right? Did we pass? The big red door comes. Did we pass? Did we pass? Well, now you have technologies such as aero barrier, a mechanized process. And I find it interesting that builders, from my perspective, should immediately take that on and go, oh, finally, I don't have to worry about this. Here's a technology. You make a phone call, and we're done. And that's pretty interesting. I think there's going to be other technologies that come along that do that. And I would say similarly, the window industry has done a phenomenal job. We're on fourth or fifth generation of low E coating, spectrally selective coatings that allow us to have the big, bright, beautiful windows that people want in their houses without the overheating and overcooling. So there's been lots of really nice innovations that, again, match up nicely with this concept of healthy, safer, durable, more comfortable, all in the same, with one decision, if you will. So systems that manufacturers provide. Yeah.
Do you think makeup air is required in probably most codes across both countries, I would say, but do you see a point where, like in HRV, ERV is going to make its way into a future code, where it's going to be mandated as part of the system, just like you would if you're going to put in HVAC, you're going to design an HVAC system, more than just say makeup air, which in some ways could be a hole in the wall.
Yes.
Do you think that will be something that makes its way into the code book?
Sure. And makeup air, the reason it made its way into the code is because it's a safety concern, right?
Yeah.
Get rid of the chimneys, you don't have to worry about makeup air nearly so much. Still some, but so it was tied to safety. So of course it should make its way into the code first, resolve that. Ventilation is more on the health side. It's been a code requirement. Ventilation's been a code requirement for decades. It's certainly been a standard. What's missing, I guess, is the need for, or the move towards balanced ventilation. And now codes are moving towards balanced ventilation.
Right.
Air in equals air out. And then heat recovery follows on to that. So even in places where heat recovery ventilation is used in every house is not necessarily mandatory. It's just that it becomes the default way to do it. If I have to have balanced ventilation, 2 fans, well, I might as well put those 2 fans in one box. Because the 2 fans are in one box, adding a heat recovery device, boy, that's pretty simple. And it gets rid of cold air complaints and moisture complaints and so on. So it becomes the default methodology, strategy to meet what is very clearly a good code requirement of balanced ventilation. Understanding that air in equals air out means healthier, safer, more comfortable. Heat recovery or energy recovery off of that becomes very straightforward. I still see some builders, mechanical guys, trying to cobble together. Well, I don't want to buy that box, so I'll buy an exhaust fan and I'll hook it up with a supply fan and I'll put in some dampers and insulate and run controls between the two. And you go, you could do that, or you could just buy one box that has all of those
Yeah.
elements built into it, plus the benefit of that energy recovery that helps manage moisture in the south and helps manage temperature differentials in the north. So there's no doubt in my mind it'll become the de facto um, strategy
Yeah.
for balanced ventilation.
I agree. So when I had you on my podcast, I think it was probably it might have been over a year ago, but you talked about recalibrating our thinking, towards building science. What did you mean by that?
Yeah, I just think, and again, another call today, young researcher at uh, at a university, as part of his thesis, he has to do an impact study of what it would mean to the industry of some of the new things that he's doing or the research that's coming along, and that's what I would allude to. We need to recalibrate because we're an industry that's so diverse, so regionally diverse, very complicated, over-regulated. It's just too easy to continue to do what you have been doing. I get why builders do that. Well, I've been doing it that way for 30 years. It's worked. Why wouldn't I keep doing it? When I say recalibrate, you need to recalibrate the world around you. What's changed about the expectations of your customers, for example? What are they willing to accept as a standard when you think about all the other things they have available to them? In your car, you can have two people sitting 3 feet apart, live at two different temperatures on the 2 hour drive from here to there. And in houses, we have one thermostat down on the main floor that's supposed to solve everybody's needs throughout the house. Wow, that's pretty interesting. So their expectations are much higher. And not that we can't meet those expectations, but we're going to have to recalibrate our understanding of when we say air tightness, for example, or when we say properly insulated or properly ventilated. Exactly what does that mean? And whatever you knew 30 years ago probably isn't what you need to know today. And to me, the most important part of the recalibration is committing yourself to, uh, I will say, education in classroom, and maybe that's self-serving as an educator, but I just feel like the industry needs that basis, and they need it regularly. It's always surprising to me. It shouldn't be a surprise because industry knows this too. You can't just say, well, I got my trade papers 20 years ago. I'm all good to go the rest of my career. That doesn't work in industry and that doesn't work in houses. We have to recalibrate, rethink. And I think continuing education credits, understanding that all of your trades folks should encourage them to go to a classroom setting or at least formal learning setting. It doesn't have to be classroom, I guess, but okay, I just need to remind myself of the physics and understand the new realities of that physics. Forget climate change. Just the fact that homeowners alone want the same humidity throughout the year. That was never done before. We used to be 20% in the winter and 55, 60% in the summer. You try to sell that to a homeowner, what are you talking about? That doesn't make any sense to them at all. I have
No.
clients right now I'm working for, all in 4 different places in North America, who are all saying to me, that homeowners who are saying, that's ridiculous that the humidity would change that much. That can't possibly be the case. So we're going to have to recalibrate our understanding of what performance means.
Yeah, what performance means. And all along the way, you and I had a really good discussion on this when I was out in Denver. The cost of coming out of COVID, the cost of building has increased just exponentially. Cost of everything really has continued to increase. And as builders, we've got to deliver these options to the homeowner without scaring them away, thinking that everything we're saying, all these things that are good that they need, they just see dollar signs a lot of times. How does a builder position themselves so that they can have this discussion with a homeowner without the homeowner, like I said, just having the knee jerk reaction that, oh, that's just all more money.
Yeah, you're just trying to sell me something, or my previous house didn't have that. Why would I need that?
Yeah.
And it comes, and thank you for that question, because it's actually been a huge part of my career is to, how do I extract the value? How do I make sure I'm getting the value? And I used to joke that I used to do some sales training. Well, I still do sales training, of course, but on custom builder side, and back in the day of acetates, you remember, you used to have overhead machines. I would collect up at the first break business cards from every builder in the room, and I'd quietly go out to the hotel lobby, have the acetate, and I would photocopy all of their business cards, and every business card you can imagine said fine quality distinctive custom home builder, right? Everybody's a custom home builder, and that's great. I'm very proud of the fact that they're proud of the fact that they're a great quality builder. The problem is everybody says they're custom, everybody says they're quality. I've only met one builder, and he didn't call himself a low quality builder, he called himself an economical builder. Okay, which was kind of a hint that you're not going to get all the bells and whistles. But so how does a custom builder extract the value? And from my perspective, having studied this a lot, we need to invest a little bit of time into understanding sales skills. And you say, I don't want to be a salesperson. Fair enough. My dad was a salesperson who would say, I'm not a salesperson. I just try to help people make good decisions. So how do I help people make good decisions? First, I need to understand what their interests are, what's most important to them. And he always said, and lots of others have said as well, they're not ready to listen to you until you've listened to them. So this is not, most builders would have this understanding, but I would say take a little more time to truly understand the needs of your builder, of your home buyers. And that really comes down to questions, and not questions like, are you interested in an energy efficient home that's healthy, safe, and durable? No, that's not a question. That's a sales pitch. What we need to understand is, and the classic example to me is, I always ask in a room, builders, who or salespeople, whatever, mainly salespeople, who here lives in an uncomfortable house? And maybe one person puts up their hand. And then I'll say, who here lives in a house where one room is a lot harder to heat and cool than another room? And magically a third of the hands will go up. So the word comfort doesn't mean anything to anybody. It's not significant in their lives. It's not something that causes them distress. The word cold, okay, or hot or sweaty nights, oh, that means something. So when we ask people questions, we have to ask questions that meet them the way they live, right?
Yeah.
Tell me a little bit about a day in the life of, tell me about how you use your house now. Well, most of the times in the living room, of course, we'd like to use the dining room, but it faces west. So we've had to turn that into a TV room because, it's too hot there when the sun's shining in. Oh, okay. That now I'm hearing about their life and what problems they have in their lives. So I always say, find out the problems they're having with their current home, find out the problems they'd like to solve, what's prompted them. And there's a classic question. What's prompted your search for a new home? What's prompted you to call a custom builder? Because there's all kinds of choices out there. Well, we went and shopped some existing houses and none of them fits our needs. Oh, tell me a little bit about that. And my own son was a great example. He knew that they wanted a bigger house, 2 kids. And they felt like they were going to buy an older home, had this idea he was going to renovate it, live downtown, everything would be walkable. And after a few weekends, I said to him, so how's the search going? He goes, it's the weirdest thing. I walk into these houses, I can hardly breathe. It's weird. I said, Andrew, don't you remember as a kid, you had mold allergies, and that's why we built a new house. Oh, because he'd not had any problems with it, he hadn't thought about it. Well, now he realizes, wow, old houses aren't going to meet his needs. It's going to be really difficult to find an old house in a market that has basements. It's going to be, and he goes, wow, that eliminates half the houses. Exactly. Yeah. So just understanding the problems people have in their lives. So it's a sales piece. It's understanding their needs, and then it's matching your story with their story. Oh, I understand that, Andrew, you've got concerns with mold, and mold actually is a moisture issue. Here's what we do to solve moisture problems in houses. And I can imagine you're making an investment this side. You'd see how that would be valuable, right? Oh, absolutely. So think about the investment they're making. Why would it be valuable to them? That would be my point. And the good news is you only need to do that 3 or 4 times. You only need to find 3 or 4 until the homeowner goes, oh, or home buyer goes, oh, I get it. You're a custom builder who understands my needs. Yeah. And I'm sure you're going to look after me throughout the process.
And build them a healthy, safe, comfortable home. They're going to become your salesman.
Absolutely.
Yeah.
Absolutely.
So what do you see coming up, maybe their challenges, innovations, opportunities, over the coming years, coming decade? What do you see that we need to be thinking about?
Yeah, and I'll start with I'll say the envelope, the enclosure, the big challenge builders have, I would say the 2 big challenges they've got perhaps is the wall. So we've done a good job of windows, mechanical systems, air tightness. Those are all, 1 phone call away, I would say. The wall conversation, depending on your climate zone, if you have any amount of heating at all, climate zones 3 and up, 4 and up for sure, it's about time we changed our wall. The reason I say that is because when I started in this industry in the early 80s, people had just nicely switched from 2x4 to 2x6 to make the thicker wall that accommodated more insulation and structural needs and so on. And it's kind of run its course, I would say. We're kind of at the limits. You can't jam more insulation in the cavity and get any appreciable amount more of energy efficiency. You just, because of the fact of the way the walls are built. Some would say we'll go to SIPs or ICF. Absolutely, because you got to improve the thermal performance of that wall. So when you look at where codes are headed with respect to energy efficiency and moving towards zero energy houses, we got to get walls higher effective R value. So a typical 2x6 wall with, the best of the insulation that you put in the cavity is 16 to 18 our effective R value. You fill it full of spray foam and you're at R18. And I'm not saying spray foam is bad. I'm just saying that's as far as you can get. And we know the sweet spot in the more southerly climates is effective R values of 25, and in northern climates more like 30 to 35. And that's tough to do with the age old 2x6 wall. And also remember that as you add more insulation, the drying potential goes down. So we're going to have to make allowances for better drying and durability of those walls. So the big challenge for builders here in the next little piece is to rethink their wall, to think about what their not their and I'm going to say their next 40-year wall is. That is, they designed a wall 40 years ago, stuck with it with a few minor changes. Now they got to look at the next wall that's going to last them the next 30, 40 years. And that you kind of got 3 or 4 choices. You could do it with systems like SIPs, structural insulated panels, or ICF, or you can do it with double walls, thicker and thicker double walls with space in between, or you can do it with the new versions of insulated sheathing, continuous exterior insulation.
So, Gord, tell us a little bit about CI, construction instruction.
Well, thanks for that opportunity. As you nicely mentioned earlier, I'm an educator, trainer, travel the country, talking in front of groups, and always knowing that in a 1-hour format we could get people excited, but not necessarily much would happen. In a 1-day format, they would get excited, they'd have some awareness, they would try to make some changes. But builders self-identified and said, I just want to go and learn this more intense. I just need to be immersed in this for a longer period of time. And that's why we set up CI Live, this wonderful facility that Justin, our partner, Justin Wilson, has set up. 12,000 square foot facility, nice classroom out front, but more importantly, the warehouse at the back, where we've got 12 different wall sections that people can pull out and have a look at and play with. We've got a little building science lab that shows heat, air, moisture flow, and how do you make that happen. We got a little 500 square foot house with 3 different mechanical systems that they can play around with and blow smoke on and see where the air moves. And it just becomes this really nice immersive opportunity for builders to look at each other, ask questions. Are you guys doing that? We're doing that. We thankfully have partners, manufacturers who have said, we love this concept. We don't necessarily need you to sell our products. We just kind of want to hang around and be there and provide you with the resources. So we like the fact when a builder comes and goes, now, where do I get that? We're able to say, here's what you take this bag, take a sample. And what we found is it really enables builders to make a quicker choice. A little example, we just had a group of builders in, custom builders who kind of wanted to get to zero energy, but knew it was going to take too long and they're busy. So they just came down, spent a couple of days with us. And over those 2 days, we were able to help them, each of them, come up with their own formula. Oh, so that's what I got to do to get zero energy? Those are the changes I have to make? Do I have to make them all the first year? No. But year 1, here's what you do. Year 2, here's what you do. Year 3, you're at zero energy. So they really like that, I would say, the immersive side of it. So that's CI Live. We hold public classes published. Go on our website and you'll find different series, one on mechanicals, one on building enclosures, one on zero energy, one on zero carbon. And then we held private sessions. So if we just had a large custom builder who brought in all of their staff, designers, not all of their staff, but a representative set of purchasing, designers, mechanical designers, and HVAC contractors. And they too wanted to hey guys, let's all just be on the same page. So we think it's a great experience. I find it difficult to train without that in front of me now, because it's nice to be able to say, here, this is the material, put it in your hands, here's how it feels, here's how it attaches. So we think it's a wonderful facility, and we just invite folks to come down and spend some time with us and play around.
Yeah, it is. It's a great place, and it's definitely a place to nerd out, geek out, whatever you want to call it. It's a ton of fun. You guys do a great job out there. I encourage anybody that's listening, if you have the opportunity, visit their website, check it out, or you may even run across one of your vendor suppliers that has a connection, wants to maybe participate. But yeah, construction instruction is very cool. So how can listeners find you if they want to learn a little bit more?
Sure. So constructioninstruction.com. They're welcome to send me an email, gord@constructioninstruction.com. We also have a free app. As I understand, it's the largest app in the construction industry, where all of our animations, all of our building science information. So go to your favorite app store, look up CI, Construction Instruction. It's a free app. And as I say, it's kind of cool because now you can go on a job site with an iPad or even your iPhone and say to your framer, here's how I want the house wrap installed, please. To your HVAC guy, here's the ERV, here's how it gets installed. So, about 100 different animations there that takes away some of the language barriers, plays out in 45 seconds as to not 45-minute videos, but 45 to minute long animations to say, hey, do you want me to play it again? Here's where the bead of caulking goes. See that? Hey, let's play that again. So
yeah, it's a wonderful tool in the toolbox. I've had the app 10 years or more for sure. There's no doubt about it.
Thanks for that.
Gord, thanks again, man. Appreciate your time, your knowledge. You're always willing to share. Appreciate that. You're a huge benefit to the industry, and we may be planning a trip out there later this year. So I hope to see you again soon.
Great. And I always appreciate the opportunity, Duane. If I can ever help on that sales conversation or specific technical conversations, let me know. Be happy to chat further.
We'll certainly do. That's a wrap. Thanks for watching. Please reach out to us with any comments. You can learn more at custombuilderonline.com or hit me up, Duane Johns, at buildernuggets.com, or you can find me directly on LinkedIn and Instagram.